Is he in there?
Yeah, I think so.
Hi, Demacia.
Hello, Sammy.
There you go.
He does that.
We're not really. So, equation of a line. Give me the equation of the line we had yesterday.
What was it?
One of them. Oh my. Y equals
50 f minus 916.
minus
916.2.
916. Okay. What did that tell me?
It told you how to find the gradient of the line of this one?
No, it doesn't tell me how to find the slope. Doesn't tell. Well, it doesn't tell me how to find the slope.
It tells you the slope.
It does. The slope is in there if I interpret
And
it.
the
Yeah.
y-intercept.
And it tells me the y-intercept.
Tells you the information you need to find the answer.
What
The
answer?
data.
Doesn't tell me to find the data.
The
No.
relationship.
I don't know the data that gave me that. I know that represents the data. But if I don't see the data, there's no way. Well, I can use that
Can
for
you-
something. What did we do at the
Can you
very
work
end?
backwards?
Hey, you're getting somewhere. What did we do at the end?
Converted it.
Don't guess. Look at your notes. What was the last thing we did? Because it wasn't converting it.
Solving for x.
Ah. There's that word.
We both.
What did I ask you to do?
Put it into slope form
that's
from
right.
gradient.
Matthew was saying. That wasn't the last thing we did. What question did I pose?
I.
Oh.
800 PhDs.
Yeah, that one. Yeah.
If y equals
For the
800, what is x?
0. Wait, no, that's not.
11.41
And how did we know that?
Because we divide. Wait.
Because we've got 800 equals 150x minus 916.2. Okay. And what did I say we needed to do at this point, Zach?
Add 960.
No, just
Oh, just
solve for x. Now, don't say, give me the answer. What is solving for x?
Find the value
Of
of x.
that gives me which answer?
to the equation.
What's the answer to that equation?
How many cheese gets eaten?
Look, there's a number there. If I ask you to solve that,
960.
what value of
What's
x?
the coordinate for 800?
150.
It's the x.
What value of x would I need to put into that equation to get 800, yeah? By solving for x, basically what I'm saying is, I want to know what value of x goes into that equation to give me the number 800. Yes? Right. Now you've already talked about what the practicalities of that is. How do we go about doing that? How did we do it?
Add 960.
So we added 900. Why did we do that, by the way?
So that x is on its own.
Okay, but why did I add 916? This, what was that, by the way? That's 1,716.2, is it?
Yeah.
Why did I add 916.2? Why does that work?
Because it cancels out.
Wasn't it 900?
It cancels out the
Negative.
subtracting 916. So what I'm thinking of is, this is the answer to the other
It was
question. I posed.
988. Well, oh, you're doing a different one.
Yeah, I did
That's
the one
the-
Nico gave me.
Yeah.
Alright. So I added that because that cancels out, like Matthew says, it cancels that one out and leaves me with, well, I have done something to x. What did I do to x?
Leave it alone.
I multiplied it by 150 and then I subtracted 900 odd, and the answer I got was, you must remember going through this kind of process before, right?
Yeah.
think of a number, multiply it by that number, subtract this and get that answer, yeah? Right. So what we do is we're unbuilding this. So, I want to know what it was before I subtracted 916. So, we add it back on, both sides, because obviously if I don't subtract it from there, the answer hasn't had it subtracted either. So now we do x was multiplied by 150, so obviously the answer is the equivalent of 150 of them. So we divide by 150.
It's
Okay.
150. Is your computer about to die?
Not die. Oh, it might be because I'm not plugged in.
Might be Namasi.
I think it struggles with the video and the it doesn't like too many things going on at once, like most of you in here. All right.
Okay. You got it.
Okay.
I didn't.
Now, if I do that, what
That's what he
must x have been?
Oh.
What must x have been
11.
for that to be true? 11.44
11.44.
round. Okay.
That's what it is.
Now, are you okay with that? So solving an equation means what value of x must have been put in there to give me this value for y. So, back to, if you are solving an equation, what has already happened?
Opposite.
The opposite. Do you know what the opposite of solving is?
Turning it into an equation.
Dissolving things.
Undissolving it.
Not solving.
Undissolving.
Subtracting.
Substituting.
Substitution or substituting. So basically, what we could have done with my line of best fit, instead of solving, would have been, well, what would be the opposite of that? So, how do I interpret these again? What was the 800?
1,760.
Number of
PhDs. Yeah, that's the PhDs. X is the pounds of cheese. Okay. Because what we were saying with our line of best fit is,
The amount of cheese eaten affects the amount of pH.
so if I want to know how many PhDs there will be this year, I need to know and substitute in how much cheese is eaten. So let's just do an alternative, which is if 13 pounds of cheese is eaten, okay, how many PhDs are expected? So we've got y equals, what was it? 150x minus 916.
I have an answer.
Can you work that out for me?
I did it.
And this time it is called substituting because we are putting the number in to the equation we've got.
It's 1033.8.
Ruining it for everyone.
My bad.
Yeah, stop ruining it.
Yeah, reading.
So we do y equals 150 times 13 minus 9. Now, what I just think substitution is a lot simpler.
Oh wait,
There's no problems. You just follow the calculation then, don't
I
you?
thought we had to replace 150 with 15.
No, you replace the x. So the 13 pounds replaces the x. It substitutes for. Yeah? Just like Man City replaced Liverpool as champions. Yeah?
Because
We replace x with 13. Alright? And what do we get as our final answer? Do we agree with David's answer? We get y equals
1033.8.
1,033.
33.
So we just do 1,034. Why can't I do 1,033.8?
Because PhDs are a physical thing
Yeah,
that
we have a
can be,
whole
like,
number.
broken.
Now, how could I turn that question into a solve this question?
You do 1,034
PH.
pH.
And I would ask
What is
how
PH?
much cheese is needed, yeah? How much cheese is needed? So depending on the order in which I go, determines whether I am substituting or solving.
Yes.
So solving is the act of finding the value that gives me the value I've already been presented with. It's the reverse process of substitution. All right. So how does it work with the stuff? Well, it's basically that was our final part of our line of best fit stuff, is to make these predictions. All right. The other side of the previous unit was, is that a reliable prediction?
No,
Why not?
because
Cheese doesn't affect.
Yeah, cheese doesn't affect PHP. It just doesn't. So
yeah,
trying to predict using that correlation is a bit
goofy.
pointless.
Zero.
Right.
Zach, you have a PhD also.
We're skipping a lot.
It's not old enough.
Impressive.
Solving equations is so small.
Okay. I tell you what. Let me. We are going to be solving all of these. Now you can see they're getting quite challenging.
The first one was quite challenging.
Now this, guys, these questions, when we, as the maths teachers, were looking at the test from last time, we were looking at questions like that and we went, oof, blimey, they're tricky.
Oh my days.
Wait. Is it blimey or blind me?
Blimey.
Say that?
B-L-I-M-E-Y.
I thought it was blind, like.
No.
I thought it was.
Right, guys, so this is where, so we need to solve the equation. Now, what is solving?
Not substitute.
The opposite of
So
substitute.
if I ask you to solve, let's look at this one. A nice simple one. You're going to have to write notes here because you're going to need some examples to go through. Right, so we're going to look at, it was 3x plus 4.
Bracket equals
Plus
Okay. Now, if I ask you to solve this, what am I actually asking for?
The opposite of substitution.
Right, but what will that lead us to? I'm trying to find
What is the
x,
value of that?
but what is important about the value of x that I end up with? What must it do?
substitute.
Okay, but what would it mean? If I find the correct value of x, what will I have done? Find the value of x that does what?
Allows a prediction.
No, we're not predict. This has not
Okay.
got an application in this one.
Allows you to find the answer of the equation.
But what is the answer? This is a kind of a general understanding thing. People mess up because they don't really understand what they're trying to do. What does this sign mean?
Equal. It's equal to negative.
So that means this side
It's equal
is equal to that side.
If
If what?
If what?
That's
If-
what I asked.
if
If I
what
find the
value of x.
will every value of x make both sides equal?
No.
Okay, let's just have a look. If x equals 7, let's substitute. 3, 7 plus 4 equals negative 3 times 7. Right, what would that give me?
3 times 11
11
is equal to negative 21.
Okay, well I'm just going to write that to start and I'm going to say 33 equals negative 21. Can you see any issues with that?
It's not true.
It's not
Absolutely
true.
not.
Good, that's all I want. It's not true. Therefore, x
It's not substitute.
x equals 7 is not a solution.
process of.
How many solutions will there be? One to this, because it's a linear system. Straight lines only meet once unless they are
Parallel.
parallel, because they meet never,
Sheesh.
or if they're the same line where they meet always. So they are possibilities. This case, all right, we need to take those into consideration, but we know x is 7 is not a solution. So Matthew quite sort of reasonably said, do we just do a trial and error process?
No.
And the correct answer to that is no, we don't.
That would take like years.
So what we need to do, let's see. So obviously the trial and error method is not going to work. So let's do 3x plus 4 equals negative 3x. This equal sign, so I'm just currently doing this with my M2s. Equal sign means that side equals that side, yeah? So if it was a set of scales, they'd be balanced, yeah? On a set of scales, if I add or subtract to one side, I have to do exactly the same to the other. And basically that's what we're going to do. We're going to do you remember what I said about deconstructing it?
Yes.
We're going to deconstruct it, so we're left with, oh well, if I take all of that off, I'm left with 1x must balance by, and that's where we need to be. So one thing I will say, we never, in my classrooms, we never move things from side to side and change signs. Now you may not have heard that, which is brilliant, but you will hear it if you go searching for videos online. If you go and speak to Dr. John in physics, he will say to move things from side to side in physics equations. That leads to mistakes, believe me. What you have to do is you have to remember something that you've done before, which is fed mass. And actually, we need to do that in the opposite order. So to be able to do it in the opposite order, we need to know what the correct order is.
Sam does.
So,
Samu.
what we do with this one is, well, we've got a couple of options. We could expand the brackets, but in this case I don't need to. Sorry, that's the over 10 minutes. I've got 3 lots of x plus 4. What was the last thing that happened to this x?
Exponent.
To multiply by 3, right?
Yeah.
Could I divide by 3? Can I divide both sides by 3?
It's possible, yes, because -3 is.
So let's divide both sides by 3, because I know I can do that to both sides. I'm going to deconstruct that. I know I can divide by 3.
Okay.
So, what am I left with if I have 3 x plus 4s, but I divide it into 3s? I'm left with only 1 x plus 4, right? So I have got rid of that. And multiplication is got rid of or undone by a division by the same amount. What's left on the other side?
X.
Negative x.
Negative x. Good. All right. This is where we actually start with a pretty high level of question, even though it seems easy. What can we do next?
Nothing.
Oh, well.
Correct.
Oh! Divide x, maybe?
Minus 4.
Right, so we could divide by x,
-4.
but it would just make it really difficult. Why do you want to do that, Tom? Because it'd leave x on its own. Should we -4? We've got to -4. What does that do? That leaves me with x equals minus x minus 4. Well, it hasn't done anything immediately, but actually it's exactly what I would have done as well.
Done, Connor.
Because it does leave an x equals. Now there is still an x on the other side,
You can just
but it's a negative x.
Add x.
Good. Now we're going to
And
add.
then it's 2x.
If I
equals
add
negative
x to that side, I need to add x, which gives me 2 x's on this side, but only -4 now on that side.
It's -2.
Because this plus 4, that cancelled, just like this negative x was cancelled by a positive x. Now what do I do? Well, if 2 x's are equal to -4, we divide it by 2, and we get 1x must be
8.
-2. Okay?
Yes.
Alright.
It's only a 10 number difference.
How can I check I'm correct?
Back of the book.
A substitute.
Thank you. Yes. I was on a bit of a roll today.
Whoa, I thought
Do you remember I started by substituting a random number like 7 in, and I realised it didn't work? Well, if I'm correct, and this is what gets me about algebra, it's like, don't put your hand up and say, Mr. Potts, am I right? You can check you're right. Just put your answer back into the equation and see if it works. Alright? That's why maths is so much better than subjects that are subjective, in that you know if you're right, whereas if you write an essay, who knows until you've actually handed it in. Right? So if I think x is -2, I've got to replace my x with -2, right? So we've got 3 times -2 plus 4 should equal -3 times -2.
It's
So that's 3 times
2.
2 should equal -3 times -2. 3 times 2 is 6.
That's also
-3 times -2 is 6. I am happy as Larry, whoever Larry is.
As
I don't
Harry.
know.
Harry.
Happy as Harry. Bob Drunk.
Who's
Alright, so we've got the process, but it does get tricky. But you've got to remember what we did was we had to think about the order in which the equation was first built up. As soon as you stop thinking about that, you will start making mistakes. Alright? You have to think of algebra as a language. How was this equation set up? What did I do to x? And in what order did it get done to it? Because you can't just start. Do you remember I said you can't move things around? You can't look at the numbers as just separate building blocks that you can pick up randomly. You've got to think of it as an operation that happens to x that you are going to undo. Right, so we've only got a few minutes. Alright. What should we have a look at?
B.
Have a look at B? Go for it.
Plus and
Let's do a nice 5x over 2 equals 4x plus 3. 5x divided by 2 equals 4x plus 3. Quickly, because Sammy, we're recording now, so don't let your views go out in public.
My what? My what?
Views.
What are views?
Your opinions.
Okay.
Right, what do we do first?
Well, you're right. Right.
Times by 2.
Good. Let's times it by 2 first. That gets rid of. Alright? Times by 2 gets rid of that one, yeah?
Yeah.
So that leaves me with 5x. Now on this side, I need to times by 2 as well, which gives me
8x.
8x's and 6. Good. Okay. Now what do we do?
Minus 6.
Minus 6 probably.
Minus 6. Okay, I do like the fact that you're not scared of the negatives. We're leaving that more x's alone, yeah? So let's subtract the 6 from both sides, and we get left with 5x minus 6 equals 8x.
And 6 again.
Why would I just redo what I've just undone? We're going to next subtract 5x's. And I'm left with negative 6 equals 3x's.
Divide by 3.
And then we are going to divide by 3, and I'm then told that for this statement to be true, x has to be
Negative
negative 2.
Again?
Again. And if we just, before the bell goes, let's do a check. 5 times negative 2 divided by 2 should equal 4 times negative 2 plus 3. So, 5 times negative 2 is negative 10 divided by 2, which is negative 5. This is 4 times negative 2 is negative 8 plus 3, which is,
Unlucky for you.
Sorry, now.
which is
Negative
negative
5.
5. So we're good and we're happy.
Hold on. Hold on.
Yeah.
Done.
Awesome.